Hello everyone. In this video, we are going to discuss about classical states of more than one system. How are we going to deal with that? So let's say there are two systems X and Y. These are our two systems. Now let's consider X has a set of classical state which we call classical state set, and let us denote it by sigma, capital sigma. And let's consider the classical state set of Y to be gamma. And now let's consider a compound system where we have X and Y together. So this as a single system we call them compound system. So a compound system is made up of a lot of individual systems. We also denote this compound system as X and Y in a bracket or directly as XY. So the question is, what are the classical state of XY? Compound system. So it is represented as sigma cross gamma equals to set of all A, B such that A belongs to sigma and B belongs to gamma. This kind of set is called cross Cartesian product. So it is basically the combination of all possible combination of elements in sigma and gamma. So let us take an example. Let's consider sigma to be 0, 1, gamma to be 2, 3, and 4. So if we make a compound system from these two, then our compound system will have states 0, 2, 0, 3, 0, 4, and further 1, 2, 1, 3, and 1, 4. Right? So this is the Cartesian product of sigma and gamma. Now let's consider a compound system having more than two individual systems, and let us generalize this Cartesian product formula. So let us consider the system having n number of individual system. So let's denote them by x1, x2 up to xn, and let's consider the classical state set to be sigma 1, sigma 2 up to sigma n, where sigma 1 corresponds to the classical state set of x1 and xn correspond to the classical state set of xn. Sigma n correspond to that of xn, right? Now if we make a compound system consisting of x1, x2 up to xn, we'll denote that as x1, x2 to xn, or we can directly denote them as x1, x2 to xn, right? Now if we consider the classical state set of this compound system, it will be the Cartesian product again. And we can generalize the formula as sigma 1 cross sigma 2 to sigma n will be the set of all tuple and tuple a1 up to an such that a1 belongs to sigma 1 and like that an belongs to sigma n, right? So let's take an example to clarify this point. So our example consists of three individual systems: sigma 1 having classical states at sigma 1, sigma 2 and sigma 3. All of them are bit consisting of 0 and 1 state in their classical state set. Then sigma 1 plus sigma 2 plus sigma 3 can be given as 0 0 0. So there are three individual system: 0 0 1, 0 1 0, 0 1 1, then 1 0 0, 1 0 1, then 1 1 0 and 1 1 1. The total 8 elements are there in the Cartesian product set, or this classical state set of this compound system, and that is determined by the number of elements in each of the individual classical state set. So it amounts to 8, right? 2 plus 2 plus 2, it is 8. So this is how we can determine the number of classical states present in a compound system. So instead of writing them as tuple, we can also write them as string, like 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. So we can write them as string. So there is a specific convention that we use to write the state for a compound system or in a Cartesian product of classical states. So we basically sequence the state lexicographically, which is basically means in dictionary order. Like here you can see, first we started with 0, then went on to 1. Actually we should see it from the last digit, so it is 0 1 0 1 like that.